Okay, ladies and gentlemen, this is lesson 1.4 or 1.14, writing standard form equations from context. And the unit is linear functions and linear equations. So once again, we always want to look at things in terms of what's our goal, what are we trying to study here. Linear functions. It's a line. So the basics of a linear function, we have a couple things I want to go over real quick. We have slope intercept form, and that's y equals mx plus b. All right. So y equals mx plus b. M is your slope. It's your rise over your run. Change in the y values of the change in the x values. And b is your y-intercept, and it's your starting point. It's just as a refresher, okay? Now we are going to talk about writing standard form equations from context. And so standard form equations from context, we are talking about this right here. So standard form equation will look like ax plus by equals c. Right, so A, B, and C, these are going to be constants. These are going to be numbers that are attached to our variables. The x and the y are going to be our variables. So what we're going to be asked to do here is to define what those variables are. And remember, we have two variables. When we're looking at a two-dimensional figure on a graph, it has two dimensions, right? It has an x-axis and a y-axis, right? So the vertical axis, which is the y-axis, and the horizontal axis, which is the x-axis. So let's go ahead and read through the question and see if we can figure out how to solve these problems, all right? All right, so it says, you have a big math test tomorrow and only have an hour, 60 minutes to study for it before you go to bed. So I always would like to underline numbers, whether they're useful or not, we'll decide. But to study for before you go to bed, and it says you feel like you might need a little more practice with graphs and with word problems. In your experience, it takes about 2 minutes for you to figure out a graph problem, and 4 minutes to figure out a word problem. Okay? So it says you are trying to decide how many graph problems to do and how many word problems to do. Okay? So that's our question right there. So I'm going to circle our question. Okay, what we're looking to do here, or at least what this is asking us for, is figure out how many graph problems, so the quantity of graph problems and the quantity of word problems. So it says choose appropriate variables for the two quantities. Okay, so when we look at this right here, we can say graph problems and word problems. We could say that we could call G the number of graph problems. We could say G, we could also just leave it in terms of X and Y, and we could say, we could also say, we could call it X if we wanted to. Okay, so let's call the word problems W. Okay? All right. So that answers question A, part A. It says write an equation that describes the relationship between the number of graph problems and the number of word problems you can do assuming you study 60 minutes. Okay? So if we go back up to the top right here, it says 4 minutes per word problem, and it says 2 minutes per graph problem. So obviously the graph problems are easier to do, right? Okay, so if we say the graph problems take us 2 minutes, we can call that 2x, right? Or 2g. Okay. So 2g, that means 2 minutes for every word problem. 2 minutes times the number of word problems that we do. So for example, if we do or not word problems, but graph problems, if we do 2 graph problems, that's 2 times 2, which is 4. Then if we add that to the number of word problems that we do, and the word problems take us 4 minutes, we can say 4w, and that's going to have to equal what it says is equal 60 minutes. Okay? All right. So it says generate a table of values with at least 5 solutions for the equation you wrote in part B. Okay, so we write an equation, and we're going to call number of graph problems, we're going to call that G, right? I'll just write a little G right there. And I'll go ahead and call the number of word problems. Oops. Call the number of word problems W. Okay. All right, so now we have to figure out a way to come up with some answers. Now, it doesn't tell us, it doesn't say, it just says at least 5 solutions. Okay, so what I like to do when we're doing this is put in, if I do 0, okay, if I do 0 graph problems, okay, 0 graph problems, what I would have to do is figure out the number of word problems that I could do in order to meet the 60 minutes. All right, so this right here, I'm going to plug in a 0 for G. So I'm going to say 2 times 0 plus 4W equals 60. Okay? So I know that 2 times 0 is 0. I can just pretty much eliminate that. It's adding 0 to anything is just the same thing. So if I have 4 times W equals 60, what do I multiply 4 times to get 60? That's what I'm asking, all right? Or in other words, I can just use the inverse operation, and I can divide by 4. So W is going to equal 15. All right, so 60 divided by 4 is 15. All right, so we got 1. All right, and let's say that I'm going to plug in, maybe I'll plug in 0 down here, okay? I'll plug in 0 for my word problems. So let's figure out the word problems. All right, so what I'm going to do is I'm going to take 2G. I need to know now what the G is, so, but I'm going to plug in a 0 for W now. Okay. All right, so that cancels out, and if I divide by 2, on both sides. Okay, I'm going to get G equals 30. Okay, all right, so I can do 30. I can do 30 if I didn't do any word problems at all. I could do 30, and that would make sense, right? I could do 30 word problem or 30 graph problems. Okay, now so if we want to look at some other numbers right in here, we can just fill them in, right? So I can plug in some numbers for my graph problems, and maybe I'll go up by 10 each time, or let's go. I could plug in 5. It doesn't matter which numbers you plug in. All you have to do is plug them in and work them out. Okay. So I'm going to choose a 5. So I'm going to plug in a 5 for G, right? So this is going to be worked out right here. So I'm going to say 2 times 5 plus 4W equals 60. Right? So I get 10 plus 4W equals 60. And I have a two-step equation right here. Okay, so two-step equation, I have to first look at it and say, what am I adding? I want to get W by itself. Well, I'm adding something. Am I adding or subtracting something from the W term? Well, I'm adding 10 to it, right? It looks like it just says 10, but that is a plus 10. So in order to get rid of that and move it over to the other side, the opposite of adding 10 is subtracting 10. So I'm going to subtract 10. That cancels out. We're going to be at 4W equals 50. Okay. And then I am going to divide by 4. And I'll get, let's see, W equals, well, 4 goes into 5 one time. It's going to be 1 remainder. 4 goes into 10 two times. Okay, and there'll be 2 remainders, so it's going to end up being 12.5. Okay, so 12.5 word problems. I could do 12 and a half word problems. So half word problems, I don't know if you can't really do a half of a word problem, but let's say that's what we come up with. So let's plug in a 10 here. Okay. So if I plug in a 10, I can either plug in a 10 or look at this thing right here, and I could skip along, right? I could do one of two things: plug in a 10, or say, okay, well, if I go up by 5 here, I'm also going up by 5 here, right? So that's the same thing as I just did. So it does talk about this being linear. This is linear. So if it's linear, then what did I do to this side? Well, that side I took away 2.5. Right? Think of it as $2.50 or whatever you want, right? But I took away 2.5. Okay. So if I take away from 15, if I say subtract 2.5, if I subtract 2.5 from 12.5, I'm going to get 10. Okay. All right. Now to make sure that that's correct, let's plug in a 10. Let's actually plug in a 10 to the W. All right. Let's go 2G plus 4 times 10 equals 60. Okay. I'm going to get 2G plus 40 equals 60. I'm going to subtract 40 from both sides. It's using inverse operations, remember. So I get 2g equals 20. Get that out of the way there. And if I divide both sides by 2, I get g equals 10. Okay? So that turns out to be right. So if I plugged in, so remember I plugged in w here. I'm just checking. All I'm doing with this part is checking. I already figured the answer out, but I just want to check to make sure that it's correct. It's a good idea to do that on a regular basis, right? So 10, the w was 10, and g was 10, so that did work out, right? Okay? So if I can plug in a 20 right here, okay, well, this increase is plus 10. Okay, so going from 10 to 20 is plus 10. Well, it's double the increase over here, so if it's double the increase of subtracting 2.5, wouldn't I subtract double 2.5 is 5, so I would subtract 5. Okay, and so that would be my 20 comma 5 is going to be my next set, right? So let's check it out. Let's check to make sure. All right, let's plug in. Let's go 2 times 20 plus 4w equals 60. Okay, so I get 40. Two times 20 is 40. 4w equals 60. Now I subtract 40. And 4w is now going to equal 20. I divide by 4. And I'm going to get w equals 5. Okay? Check. W equals 5. There you go. Alright? So that's A, B, and C for a problem that we're setting up, like I was talking about. We're setting it up into that, we're trying to make it look like ax plus by equals c. We created a standard form equation with two variables, g and w were our variables, where you have a constant or coefficient that's out in front of the g that represents 2 minutes per graphing problem. This represents 4 minutes per word problem, and this represents the total number of minutes that we're going to be studying, that this person is going to be studying. Okay? Okay. So, I'm going to go on, see if we have anything more from this problem here. We got 2 more parts of this. Okay, so 2 more parts. All right, so now what it says, it says to graph the line that corresponds to the equation. All right, so I'm just going to say, just for sake, I want to look at how far up I need to go and how far down I need to go. So if I have 0 graph problems, I need to go. Let's say that g is going to be my x variable. Like it's going to be the horizontal variable, and w is going to be the vertical variable. Okay, so horizontally, actually vertically, 15 is the farthest I would need to go up. Okay, and horizontally 30 is the furthest I need to go to the right. All right, so it has to fit. It has to fit in. That graph has to fit 30 in there, going horizontally, and it has to fit 15 going vertically. Right. So I'm just going to say. All right, so if we have, let's see. So G, the X variable is what we called it, G. Graph problems. And, well, let's say let's see. So let's say that this is going to be 30 right here. 30 right here. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, we could say that at 30, every one is going to be 3, right? So let's go 30 right here. Okay, and remember these are the number of graph problems. We'll count by 6. We'll go. So that's 30. This one would be 24. This one would be 18. Okay, this one would be 12. Then 6. Then 0. Okay? All right, and so we're going to hit, there's going to be one point right here that is a 30 comma 0, right? Isn't that right? 30 comma 0. Okay? Now, for this part right here, we have to label this side, and it's got to go up to 15. So let's say that this is, let's see, got 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12, all right, so let's say that this is 18 right up here. Go up by 3, right? That work, 15, 12, 9, 6, 3. Right? And so this right here would be the number of word problems. All right, so just real quick, I want to go ahead and plot out this. We have a 0 comma 15. That's where that's going to be. And now I can just go ahead and draw my graph. Okay. All right, and it says, can you complete 8 graph? It says 8 graph questions, 12 word problems in the time you have. Show your work. 8 graph problems. All right, so if we say 2 times 8 plus 4 times 12 equals 60, is that going to work? 16 plus 48, does that equal 60 or less? It's got to be 60 or less, right? All right, so we end up with, well, that looks like 64. 64 does not equal 60. So, therefore, no, we cannot complete 8 graph and 12 word problems. Okay, and that's number one. That's how you do number one. Okay, that's all of that. Now you can take that same knowledge to number two and complete number two.